rate of change or average rate of change formula, but this can be used for instantaneous rate of change, which will be useful for this unit and the next previous units, and especially more on derivatives. But that's not for today. Plus, I don't know derivatives. So here we have a problem set. I'm gonna read it out. The spread of a rumor is bottled by the function r to x equals 2,500 divided by 1 plus 50 times e, which is 2.718 Euler's number, I think. Euler's number? It's Euler's something. To the power of negative point, negative 0.25 times t. And where r to t is the number of people that have heard the rumor, and t greater than 0 is the number of days since the rumor for 0 less than 2 less than t less than 30. The graph of the function r and the line tangent to r and t at t equals 4 is shown. So a tangent line is basically when it touches one time on the graph. It has only one coordinate in the graph. That's it. A secant line, which I'm gonna later explain here in the video, is two dots. They touch twice on the graph with a line, and that's it. So the question is, which of these answer choices would be the best choice for finding the instantaneous rate of change? So give it a try. So this would be 4 equals t. I took out the 4. This would be wrong because this is just a coordinate. It's not a rate of change, so that's why it's wrong. It's just 50 something. I don't know what's the units. 50,000, I think. And here, honestly, don't remember what I was talking about, but I think I was confused what I was saying. So that's it. A tangent line. It touches once. That's a coordinate, and it gives you the x and y, and what's x1 and y1 is the first initial coordinate that you encounter, and the second coordinate is x to y2, and we're gonna use this formula. I went way too fast. I showed it, but I wasn't talking. That's my fault. And it's way too far, so that's why this wouldn't be the answer choice, because it's giving us a rate of change from a very long distance of days. Not distance, the time-wise as days. So it wouldn't be as accurate as having it uh, closer. Here I'm drawing a function or a graph, and I'm doing meters over time. It's position over time graph, I think. So I'm just giving an example of when 3 is it's basically the tangent, and we're trying to find the instantaneous velocity in that section. 3 exactly. We want to find that. Since this is a linear line, it will be the same for the whole segment. It doesn't matter where, it's gonna be the same. this is gonna come up later on also. So here I'm just giving an example of 3.9, f of 3.9, or r to 3.9. And for this example, I'm using f to r to r of 3.9 minus r of 4.4. Oh, my bad, that's a different one. Of 2.1, which this would be wrong. I did this wrong. I'm sorry, but yeah, this is wrong. I don't know what I was doing, but this is wrong. It should have been 3.0, as many zeros as you want, but I'll just go with zero, not zero. I would just go with 3.1 minus, or 3.1, the function of, or for this scenario, r, which is r to 3.1 minus r of 2.9 divided by 3.1 minus 2.9, which will give you your instantaneous not velocity, acceleration. And here I'm talking about secant lines. Here they intercept twice. That is considered a secant line. That's why C is wrong. But this one, since it's getting very close to the exact interval that we're the looking for the instantaneous velocity, instantaneous rate of change, that's why D will be right, because it's giving us uh, R of 4.2, R of 4.2 minus R of 3.8 divided by 4.2 minus 3.8, which will give us a rate of change. I don't know, but I can solve it right now. I didn't do. Well, actually, I don't know the prediction. You have to plug all the. I have to plug 4.2 into the formula that is given, the function that is given, and 3.8 also. But I did it for the next scenario. And here, the software when I go is going down, it sometimes erases stuff. Everything is found in AP College, by the way. So here they give us a free response, and they give us the tangent line basically, and they're asking for the approximate the it's asking for the approximation of the instantaneous rate of change. So we're gonna use these coordinates, uh 3, 9, the function of 3, 9, and t, well, not t, 4, 1, and function of 4, 1. Oh, r, not function. But here I'm writing down the equation, but implementing the inputs, so substituting the things that I'm supposed to. So here we're given uh, we're using the instantaneous rate of change, or the average rate of change formula, but it can be used for the instantaneous rate of change since we're using the secant line. Here, 4.9 and 4.1, 3.9 and 4.1 are examples of secant lines, and this would be equal to 30.50. I'm pretty sure. And here I'm reading a ball is rolling down a straight path, and its position is modeled by the function bt, where b is feet from the starting point, and t is the second since the ball started rolling. For 0 less than t less than 25, which of following would find the best estimate of the velocity of the ball in feet per second at time equals 2.5? 12.5, my bad. Um, give it a try. Here, I'm just writing. And for these previous examples, for this one, this is the position of the time. Remember that. That's very important because there's a difference from position over time versus velocity versus acceleration. So here I'm explaining why this is wrong. It's just giving us a y and an x, and that's not what we want. We're looking for the rate of change, or the speed, or feet per second squared. This would be our answer because it's the closest to 12.5, and uh, we're given our y2 and our y1 here, which is b13 minus b12 divided by 13 minus 12, which I'm giving here an example of the that equation that the function or equation that we've given, and use it to find our instantaneous speed. But here it's velocity, so it's fine to say velocity. Okay, so we move on, and here I'm gonna read. A bicycle is being ridden down a straight path, and its position is bounded by the function b to t, where b is feet from the starting point and t is the minute. Since the bicycle started traveling from 0 less than t less than 20, the graph of b is shown below. Find the velocity of the bicycle at time times time t equals 7. So you can try it on your own. Pause the video. I'm just saying that this is a function. This is a graph of position over time. So give it a shot. So we're looking for this section 7 when t is equal to 7, which is 2, but it's asking for the velocity. Velocity. Here I'm giving example on why this is not a velocity. Why? Because in position over time graphs, when you have a horizontal line, that means that you're not moving. You're constantly staying at 2. 2 will be your position. You're not moving. So I talk about when you're from 0 to 6, you're moving your position towards 2. So that gives you a rate of change. And from 8 to 17, that gives you another position, which is 11 minus 2. I'm going to stop saying stuff and let myself write before I get ahead. And I write it here down. I'll give it a diagram or example. So this is my starting point for from 8 minutes to my position, which is 11 feet, and the duration from 8 minutes to 17 minutes, which is 9 minutes in total of me increasing or not increasing, me having the rate of change. Mm. I'm sorry if everything is like really poorly done. It's actually my first time doing any of this stuff. So my goal is to help you guys pass your AP test. And yeah, so that's why your velocity is 0. You're constantly staying at 2, so you can't have velocity if you're staying at 2. And here I give you more examples. Okay. at a particle is moving on the x-axis, and the position of the particle at time t is given by x to t, whose graph is given above. Which of the following is the best estimate of the speed of the particle at t time t equals 8? And this is a position over time graph again. Remember that. I'm just mentioning what section we're looking for the speed and notating that this is a position over time graph. And guys, if I make a mistake, please correct me in the comments below so I can have the least amount of mistakes next video that I make in next video. So here I'm just gonna, I get confused here. So I should have notated it, but yes. Uh, I I doubted myself, so I tried to do everything again from the start. I was stuck here for like a couple minutes, or a minute or two. So yeah. The reason why I got confused is because I was thinking it was velocity because when it's velocity, it's it's basically linear line in position of time. I'm just circling things because I was confused. I was so confused on what I was doing. So yeah, I don't know what I'm doing there. So I think I figured it out what I was doing. Okay. So we're looking for that position when t is equal to x, which is 30. But since this is a horizontal line, the position over time slope, position over time graph, that would equal to 0 because you're constantly staying at 30 meters per second. Meters. And I didn't circle the answer, but it was 0. The answer choice. A rocket leaves the surface uh, of Earth at a time t equals 0 and travels straight up from the surface. The height in feet of the rocket above the surface of the Earth is given by yt, where t is measured in seconds. For 0 less than or equal to t less than or equal to 600, the value of y to t for selected values of t are given in the table above. Of the following values of t, at which value would the speed of the rocket most likely be greatest based on the data in the table above. Sorry, I was drinking water. I think I'm still reading it. Uh, Sorry guys if my reading is really bad. I'm mostly focused on math-based classes in this channel, so you're not gonna be seeing any time reading. So yeah, I'm not good at reading. I'm trying my best to increase my reading skills and everything else. I think the layout that school gives me is pretty bad. So we're gonna use again the average rate of change formula, which is y2 minus y1 divided by x2 minus x1. And we're gonna just do it for all of these answer choices to see which is our best choice. So give it a try and and pause the video so you can give it a try. Okay, so here we have 50. 50 minus 0 is equal to 50 minus 0 is 50. So 50 divided by 100, it's time is constantly increasing by 100, so it's fine. I put 100 without subtracting 0. So here for B, we're subtracting 400 minus 50, which is our F, or YT, which is feet. So it will be equal to 350 divided by 100. Remember, we're increasing by 100, so it's fine. Uh, I just forget sometimes to write down my math. Why it's 100. Uh, I'm not used to like slowing down. Sometimes I just like accelerate so I can finish as fast as I can. But this is an enjoyable thing. I'm able to get the opportunity to do. I changed color so it can be easier to identify. C. C is equal to 1,360 minus 400. I was struggling saying these numbers. I don't know why. So yeah, which would equal to 900 and no, I made a mistake there. But it would equal to 1,240. I didn't check it, but it should be. Oh, I don't know. I should check it later or never. But yeah, remember it's increased by 100, so that's why your x is 100 or time is 100. I think I actually solved it, which might be better. But I think it doesn't really matter. It's just like a point. It's like point something something, so it's fine. And there on the top, I put your x or your time or seconds is your input, and your feet or the output. I don't know why I was going over that, but yeah, I think it's good to go over it. Sometimes you skim over it when you're learning algebra 1 or algebra 2 or pre-algebra, and your rate of change will be 12.4. So for D, I'm gonna change color to green, and for the whole video, it's gonna be green. So it's gonna be 3,200 minus 1,360 divided by 100, of course, but making sure. Remember, it's increasing by 100. We're not skipping around. And your answer, I'm pretty sure I'm inputting everything in the calculator in this section. So your rate of change will be 18.4 feet per second square. Feet per second, feet per second. I'm not giving them the acceleration. My bad. I sometimes struggle with differentiating what's speed, precision, and velocity, but I think I've come to understand it lately. Here, the position of a particle is moving to the right, and the x-axis is given x to t, where t to t, x to t is measured in inches, and t is measured in minutes. For 100 less than or equal to t, less than or equal to 100 is if y equals x to t is a linear function. Which of the following would most likely give you the best example of the speed of a particle in inches per second, inches per minute at time t equals 20? It's a linear function, so I'm gonna draw a linear graph. And I say this is a very ugly line, so I rewrite it. So there you go. This is somewhat linear. It's a line. Yeah, I was getting confused when I was reading stuff because I don't read and I should read. But here we have we're looking for the speed of a particle, and you can stop the video so you can try on your own. So the reason why it's not A is because it's giving you your Y, and we're looking for the speed. So yeah, that's why it's and your speed is feet over second, feet over minutes. I made a mistake there, so my apologies. And here we're given Y divided by our minutes, but you'll be tempted to pick this one, but it's not. Since it's linear, your your speed is already given to you, which is which your speed is the interval from 100, 100 over 100, which is 1. And yeah, 100 and 100 over 100 is 1 feet per minute. And that's why the slope of the graph of equals y equals x to t would be the answer for this following question. Here we go to our last example, and at a particle is moving on the x-axis, and the position of the particle at the time t is given by x to t, whose graph is shown above. Which of the following is the best example, or best estimate of the speed of a particle at the time t equals 4? So for this one, we're looking for the speed for t equals 4. Remember, this is position over time graph. You can stop so you can try it on your own. Hello and welcome back. And here we have a position over time graph. I'm gonna use example of meter per second square. Meters per second. Meter per second square is acceleration. This is position or speed. So I'm gonna use 30. 30 because it's anything on that line, that line that has a angular slope to it. I don't know why I said angular slope, but a slope. And I'm gonna use 10 because it's the y-intercept. And since it's the y-intercept, the time would be, or the seconds would be 0. So 30 is 30 minus 10 divided by 4 minus 0. And since this is a linear line, a slope, this would give us our actual slope or slope or rate of change. So that's why it's 5. Bye and thank you.